All right, hey everyone. Thanks for having me here today. My name is Shane Glass. I am a developer relations engineer in Google's open source program office. Okay, I have an unpopular opinion, and I cannot keep it to myself any longer. And that is that AI might solve your data problem, but open source already can. Look, at some point, we've all seen the impacts of weak data fundamentals, right? Maybe it was a dashboard that incorrectly reported some of your key metrics and wasted the time and money because it led your teams in the wrong directions. Maybe it was a bad prediction from your ML model that was based on faulty input data. Or maybe, like me, you yet again fell victim to the small sample size and convinced yourself, at least for a week, that this was the year for your college football team. As a South Carolina Gamecocks fan, that's on me. I really should know better by now. Go Cox. And yet, everybody in this room, or at least every data practitioner in this room, has heard someone say that AI means you'll never have to think about data fundamentals again. But I'm here to warn those people. That's not how AI works. At least, not right now. Look, the pace of innovation at AI is simply incredible, and I don't think that's going to change anytime soon. So it's entirely possible that in 3 weeks, someone will come along and prove me 100% wrong. But I do think that even if that happens, this reframing will remain true, and that's why I made it the title of this talk. AI should not replace well-built data fundamentals. Okay, I see a lot of heads nodding in this room, and there's one person in the back quite literally jumping for joy, so I'm guessing this isn't entirely new information. And to be clear, I'm an advocate for AI. AI is truly, positively transforming how technical practitioners use and build their data infrastructure. But we can and should have a more precise conversation around how to use AI to help you build your data fundamentals, not replace them. And since the best uses of AI are, in my opinion, built on top of strong data fundamentals, not in their place, this means it's actually more important than ever to understand how to build strong data fundamentals that support high-quality data that your users can trust. Now, before we go too deep, let's define what we mean when we say data fundamentals. For this talk, I want to focus on these 3 pieces: data storage, data movement, and data transformation. I'm focusing on these 3 today because I think it's unlikely that AI will abstract these away, even long term. That's because movement and storage require a physical interface with hardware before you can even really work at those. And transformations, I think, will continue to be cheaper, done once in a centralized manner, rather than being repeated during every analysis. And since our data fundamentals have to support an entirely new world of downstream use cases, we also have to update the requirements for our data fundamentals. Even though the job to be done remains the same, whether that's move data or prepare data, our downstream use cases are continually evolving. So the tools that we use to build our data fundamentals must be scalable. They must be able to efficiently and effectively support workloads of varying size and throughput. It must be flexible. You must be able to offer support for a wide variety of data structures, connections, and use cases. And it has to be interoperable. It has to be able to support a litany of downstream tooling across several use cases, like query engines, BI tools, AI models, ML, etc. Any data fundamentals that do not meet these requirements absolutely will put your organization and teams at risk because it won't be able to meet your team's evolving data needs. So let's talk about how AI can help you build your data fundamentals in order to meet these requirements using open source tooling. I think we can think about how to use AI with open source tools a little bit like cleaning dishes, even though I do love open source and I do not like washing the dishes. Building with open source tools directly is a little like hand washing dishes. You absolutely can hand wash dishes. And there are a lot of good reasons you should do so. In fact, there are probably times you absolutely must do so. But just like using AI to build with open source, dishwashers are a great tool to help you get things done faster, easier, and at a much greater scale. Hey, dishwashers even meet our requirements, right? They're scalable. You can wash a single dish or a full load. They're flexible for shorter and longer cycles, and they're interoperable. You can put just about any dish in the dishwasher. At least that's how I use dishwashers. So with that in mind, let's wash some dishes. Metaphorically, of course, no one actually wants to do dishes. We'll review data fundamentals, we'll identify some open source tooling that can meet our requirements, and we'll talk about how AI could simplify building with open source tools. I'll also point out some places where open source tools might not be the best fit, because I don't want to leave you stuck with a one-size-fits-all solution that actually doesn't fit all. Let's start with data movement. A confession, as much as we data engineers enjoy doing so, we don't build data pipelines just for the sake of moving data. We build them because there's some downstream user that needs data in a particular structure or timeliness that isn't available already. The data users of the past might have been okay with a data pipeline that only wrote a single batch update to the same global region every day. But today's data users, no way. They require continuous data updates with minimal latency, and as data sovereignty and privacy policies are implemented around the globe, writing all of your data to the same global region just isn't a viable option anymore. The right pipelines must ensure that the right data is written to the right geographic and technical locations at the right time in the right way. Now, if this all sounds incredibly complex and complicated and challenging, well, that's because it is. Thankfully, we can start cleaning our dishes with Apache Kafka and Beam. We can use these to capture and stream data into storage with minimal latency so that users can immediately leverage that data to unlock new value for your business. Maybe that's an AI pipeline that detects credit card fraud so that you can block fraudulent transactions rather than trying to get your money back later. But Beam isn't just built for streaming use cases. A managed Beam offering like Google Cloud's Dataflow can leverage Beam's flexibility and scalability for massive batch transformations too. I've personally seen weather companies that use Dataflow for both streaming real-time observations into their predictive models and batch processing decades of satellite imagery to retrain and improve those models. But hey, maybe Beam's not your flavor. Apache NiFi could also be a great option here as well. Our dishwashers in this case are AI coding assistants like Gemini CLI or Gemini Code Assist. They can make it easier to write code for Beam's programming framework in order to simplify development, debugging, and deployment. But what about use cases where a dishwasher isn't right? Maybe pipelines that require a broad spectrum of connectors to SaaS apps like Slack, Asana, Salesforce, etc. This is a place where a proprietary pipeline like Fivetran or Airbyte probably makes the most sense. The specs for SaaS APIs change so rapidly and so frequently. It's just an incredible amount of effort to maintain your own pipelines here. Honestly, I usually advise people that it's more effort than it's worth. I guess if we stick with our metaphor, this is kind of like hiring someone to clean your dishes for you. I don't know. Okay, now let's talk data storage. So we as a community talk a lot about vendor lock when it comes to storage. But I think the greater risk is actually tooling lock. Today's cloud platforms offer a broad variety of both first and third-party tools to help you unlock value from your data. And I think that mitigates a lot of your vendor lock risk. But what if your storage layer locks you into a specific analytics tool and your analysis evolves in a way that that tool just doesn't support anymore? Or what if your tool's roadmaps and focus drift away from your analysis needs? Historically, or at least 15 years ago, there wasn't a whole lot you could do about that. You were kind of stuck. You were locked into that tool. Why? Well, that's because you got the best performance by optimizing your data storage specifically for that data warehouse. You had to be really particular about co-locating data and structuring your tables to optimize for your query engine's performance. And this became even more important as your data volumes grew increasingly large. It was really constricting, it was really frustrating, and it left you locked into that tool. Tool-specific storage like that just isn't a viable option for most teams these days, since your data storage has to support a wide range of tools. And today's workloads demand data storage that meets our requirements: scalable, flexible, interoperable. Thankfully, the hand washing with Apache Iceberg can do all these things. It's the open source table format that brings the flexibility of data lakes and combines it with the structure of data warehouses. And with a managed Apache Iceberg offering like Big Lake tables for Apache Iceberg and BigQuery, you can simplify your open source implementation with automated table management. That way you're not spending time on implementation details like table compaction and others. Plus, your AI workloads actually benefit because they can take advantage of the Iceberg metadata files to understand each table structure. The dishwashers here are AI-powered storage optimization tools like Gemini and BigQuery, with intelligent recommendations for partitioning and clustering your managed Iceberg tables. Or it could even be an openly available model you've deployed that can continuously monitor your query logs and identify underused data that can be rolled off to a cheaper tier of storage. Caveat here, I really recommend a human in the loop for that process because you may have a major reanalysis coming up that wouldn't be reflected in your query logs. There are other open source options here, like Delta Lake from the Linux Foundation or Hoodie, and there's a litany of proprietary storage options as well. I think the industry is standardizing around Iceberg at this point, which is why I recommend it. But the open source and proprietary alternatives do have specific benefits that might better suit your needs. Finally, let's dive into transformation. We've talked a lot about the variety of downstream use cases your data supports, and about how these use cases require different data structures, aggregations, and so on. But now, with AI workloads growing rapidly, the demand for feature engineering is growing rapidly too. This adds a new dimension to our flexibility requirement. Your data transformation tooling still has to meet the traditional data cleaning and quality requirements that every downstream user demands. But now, it also has to support cutting-edge feature engineering that enables your teams to train AI models custom fit for your mission. And a transformation tool should, in my opinion, be flexible enough to take advantage of a wide variety of query and compute engines. If you didn't know any better, you might think that this portion of this talk is sponsored by the Project Management Committee for Apache Spark, given how well this fits these requirements. To be clear, I am not sponsored by Spark, but I am open to a paid sponsorship. If you're a Spark PMC member, call me. Now, it's really just that Spark has been the tool of choice for data engineers for a long time, and Spark ML has incredibly robust support for feature engineering. Google Cloud Serverless Spark can help you with highly scalable infrastructure, and stored procedures for Spark and BigQuery help you push your transformations down to the query engine. For a long time, data transformation was heavily dependent on proprietary solutions like Informatica, but I don't think that's the case anymore. Spark and other open source tools give you the flexibility and interoperability that your modern workloads demand. Our dishwashers in this case, I think, are the most advanced tools to support your work. For example, the BigQuery data engineering agent helps you build data pipelines that use open source tooling based on your natural language inputs. There are more proprietary and open source transformation tools than I can count, but I think that's for good reasons. Data transformation is where the tooling requires the most specialization. For instance, Ray is really well optimized for building and scaling AI workloads, dbt for leveraging the power of your data warehouse, and Apache Airflow or Flight from Linux that orchestrate pipelines that use both open source and proprietary tools. Okay, so we've seen at this point how to build your data fundamentals, but I do have to address this guy. This is Lamar. He's the AI elephant in the room. Yeah, AI is evolving rapidly, and you might see a very different version of this talk next year if they'll have me back. And we have seen how AI can help you build your data fundamentals, right? I can think of dozens of examples when AI tools help me solve problems in minutes or hours rather than days. And I love that they help me focus on how to architect something rather than having to focus on having to execute a specific architecture. But these AI tools, whether we're talking about proprietary or open source tools, are most effective when they stand on the shoulders of the open source giants that build your data foundations. For example, even in what we discussed today, you still have to understand how to define your requirements and design your architecture for your data fundamentals, even if you do use AI and Lamar to help you with your implementation. Maybe all this will change someday, soon. I have been wrong before. Please don't ask for references, there's too many of them. But I do firmly believe that the data practitioner of the future will be at their best when they have a strong understanding of these data fundamentals and open source tooling so that you can use AI to better build your data fundamentals. So it's my hope that the next time someone tells you, but AI means we never have to think about our data fundamentals again, you can use this talk to help them understand AI should not replace well-built data fundamentals, and that the best data fundamentals are built by practitioners who understand open source tooling and how to use AI to build their data fundamentals. I really appreciate your time and attention here this morning. This was awesome. Thank you. I should not have led this paragraph with that. Real quick, my buddy and I, Lamar, will be at the Google Lounge downstairs. I love talking about this stuff, if you haven't noticed. So stop by throughout the day, you can chat. There are outlets to charge devices, and more importantly, for people that are, well, let's just say not young in the back, like me, there are comfortable places to sit down. Thank you very much. Looking forward to chatting with everybody.